Okay, today we're going to be working on lesson 7.2, Real Zeros of Polynomials. We have a couple of theorems that we're going to be working with. The first one here is a remainder theorem, and basically what all that says, if you want to evaluate a function at a certain value, meaning just plug it in for x, it's the same as a remainder as if you use synthetic division. So I want to know what is the value of f of 3. I could plug f of 3 into all these x's here, but we're going to do this with the remainder theorem. So I want to know what 3 is. Using synthetic division, we take the coefficients of all the terms, and we do want to make sure that we're not skipping any terms. So the exponents are going down 4, 3, 2, 1, so we have them all. If one's missing, you'll need to put a 0 in its place. And we're just going to perform the synthetic division. Bring the first number down. 1 times 3 is 3. Combine these and we get 8. 8 times 3 is 24. Combining these two terms, we get 30. 30 times 3 is 90. Combining these two terms, we get 89. And lastly, 89 times 3 is 267. Combining the two terms here, we get 265. The remainder would be the same as if we plugged 3 in for x. Just a quick, easy way to get a value for that. Let's try the same thing here, but for this function. So we're going to use 3. It goes in the corner by itself. We list out all the coefficients. So we have 3, 2, -7, 20. I'm missing the x term, so I'm going to put a 0 as a holder spot, and then -9. Bringing down the first term, 3 times 3 is 9. Combining, we get 11. 11 times 3 is 33. Combining like terms, we get 26. 26 times 3 is 78. Combining like terms, we get 98. 98 times 3 is 294. Combining with the 0. And finally, 294 times 3 is 882. Combining with the like terms, we have a remainder of 873. So we can say f of 3 is equal to 873. Okay, we also have what is known as a factor theorem. So we'll move the notes down. Basically, what that's saying, if this is a factor and I plug k in for f over here, we should get 0. So I want to know is, I'm going to use this to factor this whole guy completely. As it is, x cubed minus 7x plus 6 is unfactorable. So first thing I'm going to do is put 2 in to the synthetic division. Using 2, I know it's a 0. We have a coefficient of 1. It is missing the x squared term, so we put a 0. Minus 7 and 6. Bring down the 1. 1 times 2 is 2. Combining, 2 times 2 is 4. Combining, we get -6. If x is a 0 of the function, you should get 0 as a remainder. Since we started with an x cubed, this next term here will be 1 exponent down, so it's going to start with x squared. So it's going to be 1x squared plus 2x minus 3. I can now factor that. That is a factorable quadratic. And we're going to have plus here minus here. So x here would equal -3. X here would be 1. And they didn't ask us to solve, actually. They asked us just to write this as a factored completely. So from the x equals 2, the factor would be x minus 2, x plus 3, x minus 1. Like I said, I went a step further and solved them all. But, read the directions, make sure you're answering what's being asked of you. Fundamental ideas in algebra. Basically, we know all this. It's just saying if the degree is 3, for example, the example number 2, then you will have 3 solutions to that polynomial. It's just also saying if k is a 0, the remainder will be 0. And we talked about when last unit that if it's repeating evenly, it could bounce off the graph or pass through looking like a cubic. All right. We also have the rational test, and it's just saying the possible rational zeros are what we're looking for here. So if we have a term, f of x is equal to px to the n, and it's going all the way through, and then you have a constant q on the end here. It's saying all the factors of q divided by all the factors of p will give you the possible zeros of the function. Now we have graphing calculators. We're able to see where they pass through the x-axis, but if you didn't have that ability, it would help you to narrow down which to choose. So I'm just going to list here the possible candidates. We're not going to do anything with them. We're just listing off what the possible candidates are. And the way I do this is first I take all the possible factors of 8. So that'd be plus or minus 1, plus or minus 2, plus or minus 4, plus and minus 8. And then I'm going to divide that by all the factors of 3. Obviously 1 is a factor of 3. I divide any of these by 1, we get the same, so I don't need to repeat that. And now I'm going to divide them each by 3. So other options are plus and minus 1/3, plus and minus 2/3, plus and minus 4/3, plus and minus 8/3. So I know just looking at this function here, there are 5 possible solutions because the highest exponent is 5. And of those would have to come from this pool here, and we can figure them out by testing each using synthetic division. But again, we're not going to do that right now. We're just asking for the possible zeros. Same thing here. This function here will have 3 possible zeros. We'll have 3 solutions because it is a 3. We're just going to get the list of possibilities. So our factors are 9 are plus or minus 1, plus or minus 3, plus or minus 9, divided by all the factors of 2, which are 1 and 2. 1 we don't do anything with, plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. So again, those are all your possible solutions. Turning your papers over, we're going to talk about Descartes' rule of sign change. Basically, it will let you know how many positive real zeros you get or how many negative real zeros you get. So the first thing we're going to do is just look at this. As it is, we're going to look at the sign changes to find out the number of possible positive solutions. So I have one sign change here, then it's the same, and another sign change here. So there's 2 sign changes in this polynomial. So for the positive zeros, we're going to have 2, or it's going to decrease by a factor of 2 or none. So there's either 2 positive or there are no positive solutions to this polynomial here. I know there is a total of 6 solutions total. To find the number of possible negative solutions, first you need to find f of negative x. So if I put f of negative x in there, I'm going to wind up with 2x to the 6th power minus x to the 4th plus 2x cubed plus 3x plus 1. So the constant won't change, and if we're putting in a negative x, only the positive, the odd exponents will see a sign change. So let's look here. I have one sign change here, another here, and then the rest are all positive. So again, there's only 2 sign changes, which means negative solutions. There's either 2, or it decreases by a value of 2 until you get to 0, or none. So at most I have 2 positive and 2 negative, but there's a total of 6 solutions here, which means I will have at least 2 imaginary solutions as well. So if I had 2 positive and no negative, that means I would have 4 imaginary. So that is what Descartes' rule of sign does. Again, what that does is, if you don't have a calculator, see where you cross the x-axis, it helps you narrow down those choices that we're doing with the Q over P. Let's look at example number 5. Saying using Descartes' rule of sign and rational zeros theorem to find all the zeros of the polynomial function. So we have some choices here. Our choices would be, let's see, plus and minus 1, plus and minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. So those are all the possible ones that we can choose from. Here's a little trick here. If you add up your coefficients, so 1 plus 8 is 9, plus 11 is 20 minus 20. If the coefficients equal 0, you know that positive 1 is a factor. So I'm going to start my synthetic division here. So we're going to use 1, because I know that is 1. There's 3 total. I'm going to list off our coefficients. Run the synthetic division. I know 1's a factor. I should get a 0 for the remainder. So 1 times 1 is 1. Add them together, 9. 1 times 9 is 9. Add them together, 20. 20 times 1 is 20. We do get a 0. They're asking me to find all the real zeros. Since this was a cubic and now I'm at a quadratic, I could see if I can factor this or use the quadratic formula. Since we started with x cubed, this is going to become x squared plus 9x plus 20. It is factorable. The other zeros here are going to be x equals negative 5, x equals negative 4. So all the solutions are 1, negative 5, negative 4. Okay, last problem here. We want to solve, oh, it's not the last one, it's almost second last. Solve this polynomial. It's a 5th degree polynomial. So that means there's 5 possible solutions. I'm going to need to run the synthetic division until I get down to a quadratic. So I'm going to have to do it at least 3 times to go from a 5th degree polynomial to a 2nd degree polynomial. If you add up all these coefficients, they do zero out, so I know 1 is in fact a solution to this. So 1 minus 5, 12, minus 24, 32, and negative 16. Running through the synthetic, we bring down the 1. 1 times 1 is 1. Combine, we get negative 4. Negative 4 times 1 is negative 4. Combine, we get 8. 8 times 1 is 8. Combining, we get negative 16. Negative 16, I get positive 16. And I should get a 0 because I do know that is a solution. Again, we could start just testing all the numbers. We could try negative 1 and then just going through here. Possible solutions would have been plus and minus 16, plus and minus 8, plus and minus 4, plus or minus 2, plus or minus 1. Divided all through by 1. I did look on a calculator to see where they were passing, and I did see that 2 was a solution. So now I'm going to run the synthetic division using 2. Move that up a little bit. And repeat. Bring down the 1. I get 2 combining like terms, negative 2. Negative 4 combining like terms, I get 4. 8, negative 8, negative 16. I found another 0. I've run 2 iterations here, and when I looked on the graphing calculator, I did see that it was bouncing off 2. The graph was bouncing off 2, which means 2 is occurring 2 times. So I'm going to run 2 again. Bring down the 1. 1 times 2 is 2. I get 0. 0, 4. I get 8, and another 0. So now I'm down to a quadratic. I've run the synthetic division 3 times. This becomes x squared minus 4. And when I go to solve this, not minus 4, plus 4. When I go to solve this, I get x squared is equal to negative 4. X is going to become plus or minus 2i. Those are imaginary solutions, and they were just asking here for the real solutions. So our real solutions are going to be 1 and 2, and this 2 has a multiplicity of 2. That does give me a total of 5 though. 1, 2 happening twice, and then plus or minus 2i. And there's the 5, because I know this polynomial has to have 5 solutions. The last theorem that we're going to talk about is the intermediate value theorem. And it just kind of lets us know, is there a 0 between a certain interval? So what I'm going to do is evaluate f of negative 3. You can do synthetic division. I'm just choosing to plug it in this time. Minus 10 times negative 3 plus 9. That gave me a total of negative 42. And on the other extreme, I'm going to find what is f of negative 2. So again, plugging in for x. That comes out to be a total of 5. Since there is a sign change in between these two intervals, that means at least a 0 exists. So at least 1 0 exists in this interval. So again, you guys will have calculators with you. It's going to be really important that you show your work, because we need to make sure that you understand how all these theorems work as well. We're done for today. Next time we'll be working on 7.2.